everyone, this video will be about 11.6 z-scores and standard normal distribution. So a z-score, this is a value that shows how many standard deviations a data value is from the mean. So when the z-score is positive, that means the data value is above the mean. And when the z-score is negative, the data value is below the mean. When z is equal to 0, that means the data value is the mean, or equals it. So to find the z-score for a data value in a set that is normally distributed, we want to use this formula. Z is going to be equal to x minus mu over sigma. So what we do is we subtract the mean from the data value and then divide it by the standard deviation to get the z-score. A radar detector records the speeds of a group of cars that pass by. If the mean is 46 miles per hour and the standard deviation is 2.8, find the z-scores of each data value. So my mu is 46, sigma is 2.8. I'm just going to be using this formula to find the z-scores for each of these data values. So z is equal to 52, which is my data value, minus the mean, divided by our standard deviation, which will get me 2.14. Our next problem, 42 minus 46 over 2.8, and I get negative 1.43. So you can see that A was a positive value, B is a negative value. So since A is positive, this data value is above our mean, which obviously we can tell because 52 is above 46, and 42 is below our mean since our z-score came out negative. So try C on your own. I'm going to move on to 3. So now we have the mean number of total miles ran last week by each member on the track team was 4, and standard deviation of 1.2. If Clay's z-score was 2.5, how many miles did he run? So now we have the z-score. We're trying to figure out what his specific data value was. So we're trying to find x. We have z of 2.5, and now we can back solve to solve for x. So 2.5 is equal to x minus 4 over 1.2. Remember that to solve for x, whenever we have a denominator, you're always just going to multiply by that denominator on both sides to get rid of it. It makes it a lot easier to solve. So we have 3 equals x minus 4. Add 4 to both sides, and we get x equals 7. So Clay ran 7 miles with a z-score of 2.5. Number 4, a set of test papers is normally distributed with a standard deviation of 5. Riley scored an 83 and has a z-score of negative 0.4. What's the mean? So again, we're going to solve for the mean because we have all the other parts from the formula. Negative 0.4 is equal to 83 minus our mean mu over standard deviation. Again, we're always going to multiply by the denominator just to get rid of it. It makes solving easier. 5 times negative 0.4 that's -2, equals 83 minus mu. Subtract 83 from both sides. I get -85 equals negative mu. So the mean score of the test papers was 85. Last one on this page. The heights of a group of trees is normally distributed with a mean of 14.3 feet. If the z-score for a 20-foot tall tree, so x is 20 foot feet, and the z-score is 1.9, what is the standard deviation? 1.9 is equal to 20 minus 14.3 over sigma. This one's no different than the ones before. You always multiply by the denominator to get rid of it. Just brings it to the other side. 1.9 sigma equals 20 minus 14.3 is 5.7. And now I'll divide both sides by 1.9. This is a 1. And I get sigma equal to 3. So my standard deviation is 3. So as long as you have 3 of the 4 parts of this formula, you can always solve for the 4th. Let's go to the next page. Standard normal distribution. So z-scores are often used so that we can standardize the normal distribution, and it allows us to find certain values that we it allows us to find the probabilities of things, so it makes it a lot easier when we have the z-score. Standard normal distribution is when we have a normal distribution where mu is 0 and sigma is 1. So the mean is 0 and the standard deviation is just 1. So then our bell curve looks like this. The distribution is standardized by the z-score, like I was saying. And for these problems, it's going to be a lot easier to do them with a calculator. So I'm going to talk through these steps, and again, if anything's still confusing, just let me know and I can make a separate calculator help video on this. So when you go into your TI-84, I'm not really sure whether this is necessary, but why not do it just to get it out of the way and make sure that your answers will be correct. So you want to change your window dimensions to this by just clicking window and then changing the x min max and y min max to these values. So to graph the curve and find the probability, we're not actually going to graph it. We're going to do a little different steps from this. It actually makes it easier and faster. So we do want to find the z-score for each data value. Some of them we already have the z-score. If we don't, we have to solve for it, and then we can use these calculator steps. So once you have a z-score, you want to hit second and go to vars, hit second vars, which is the button right next to clear, and that takes you to the distribution. Takes you to the distribution functions. So you're not going to arrow over to draw. You aren't going to pick shade normal. You're just going to pick normal CDF, which is number 2 on the second vars page. So normal CDF. Once you click normal CDF, it'll take you to this screen, and you want to put your lower and upper bounds. So it all depends on what your problem is, but once you put the lower and upper bounds, you can then hit enter, and it'll tell you what the probability is. So let's go through some examples to see how that works. The golf scores in a tournament is normally distributed with a mean of 76 and standard deviation of 2.6. We want to find the probabilities. So we already have the z-score in number 6, so we don't actually have to solve for it, and this one will be really quick to just use your calculator to solve for the probability. So since it's asking for the probability of z being less than 2.1, 2.1 is our maximum value, or our upper bound. Since we want probability of z less than, our lower bound is going to be negative infinity. And so how we represent negative infinity in the calculator is we use -1, the e button, 9. So really that's just like a really small number. And I'll write those help things on the side after. So you put -1 e99 for your lower bound, 2.1 for your upper bound in this calculator screen, except instead of say normal, it will say normal CDF. And enter, you will end up with the probability of 0.9821. For some of these, you have to find the z-score, so you're just using the information here where we have mu 76, sigma 2.6 to find our z-score. So z is equal to 74 minus 76 over 2.6, and that gives me a z-score of negative 0.769. So since this is also a less than, it's finding the probability that your data value is going to be less than 74. The z-score for this value is negative 0.769. So that is our upper bound. Since it's finding less than, our lower bound is going to be the -1 e99 again. So really what we're finding, because we're standardizing this so we can use the normal CDF function, is the probability that z is less than negative 0.769. And that is 0.221. When you have z greater than a value, that means that this will be our lower bound. And our upper bound would be positive infinity. So we use 1 e99. A problem like this where we have z in between two values, well, we have our upper and lower then. The lower bound would be negative 0.2. The upper bound would be 1.8. So we put those as our upper and lower bounds in the calculator. So for 9 and 11, make sure you find the z-scores for each of these values so that you have the correct upper or lower bound that you're going to be plugging in. And then you can find the probabilities with the calculator function. So I do want to just write what you should use for negative infinity or positive infinity. So for negative infinity, again, we're using -1 e99. And for positive infinity, we're using +1 e99. And just some other tips and hints. When you have z less than something or x less than something, you're using negative infinity as your lower bound, and your upper bound is the z-score. And then when we have z greater than a value, it's opposite. So our lower bound is the z-score. Our upper bound is infinity. And don't forget, negative infinity and positive infinity are these numbers typed in the calculator. And then, like I said, for like number 10, you have both ends, so you're just using those numbers. You won't be using infinity or negative infinity. All right, so again, if you need the calculator steps shown to you like on a calculator, let me know. I will make that video. All right, bye.